In this video, I'm going to explain to you how to wire OR and AND circuits, and why OR and AND is important, and what is a logic gate, and the role of a transistor in logic gates. Now, if we look at this first quick view of what we're doing here, we will see that these two transistors are labeled N. The only difference is between one wiring and the next is, in the first one, both are wired to ground. In the second one is wired to ground, and the other transistor is wired to the transistor that came before it. So we will find out the difference is the first one is called a parallel circuit, which is equivalent to the logical operation OR, and the second one is called a series circuit, which is the equivalent to the logical operation AND. Let us look briefly at two ways switches can be connected. The first arrangement is called a series circuit. Here, two switches are connected one after the other. For current to reach the bulb, it must pass through both switches. If the first switch is closed, but the second switch is open, the circuit is still broken. Light comes on only when the first switch and the second switch are both closed. This is why two switches connected in series behave like the logical operation AND. Okay, here's switches wired in parallel. Parallel means there's two wires. Each one's got a switch on its own wire. So obviously if one is open, another one's closed, the electricity can still flow through to the bulb because there's two paths. Each wire provides another possible path for the current. If the upper switch is closed, current can flow through the upper branch and the light comes on. If the lower switch is closed, current can flow through the lower branch and the light also comes on. If both switches are closed, current has two available paths and the light remains on. The light is off only when both switches are open. This is the same as the logical operation OR. Okay, first we plug in the ground wire, then we plug in the 5-volt power. We bring those down to the rails. When the breadboard is turned this way, the positive rail is on the bottom, the red one, and the blue rail is on the ground is on the top. If you were to turn the breadboard upside down, they would be on the opposite sides. That can lead to some confusion. Now we plug in our NPN transistor. Now, it's not always visible on the transistors that you have, so you have to look up the model number. Here on the Tinkercad, we can see the letters CBE, meaning the collector is on the left, the base is in the middle, the emitter is on the right. Again, what the transmitter does is when we send power to the base B, it allows current to flow into the collector and out the emitter. We plug in another transistor. Now we bring power down into pin 29 from the positive rail. Now we plug in a LED here and a resistor. Okay, the anode side is the positive side. It's got the longer leg, but here in Tinkercad you can hover your cursor over the diagram and it tells you. Then we plug in a resistor. This resistor is 1K ohms, and it's in the same row as the positive power that we brought down and plugged into position J29. So we're bringing power to the LED. Now what we've done is we've gone from the cathode side of the LED to the collector side of the transistor. Okay, now we're bringing in a resistor, another 1K resistor, to bring power to the base of the transistor on the right. This will let us send power to turn the transistor on. When you tap the resistor up on the middle right, a little window pops up and tells you how many ohms it is. Now we can see that resistor is plugged into pin 10. Here's the idea. These things need to be wired in series in order to do the logical AND operation. Therefore, normally we would take the emitter side of the transistor and send it to the ground to complete the circuit. But we want to have two steps. So we take the emitter, which you can think of as the output of the transistor, send it to the collector of the second transistor. See, it's on the same row up and down as the collector, so that whole row has power flowing through it. We'll end up controlling it with its base as well. Now we bring a resistor down from pin 10, pin 11, it's from pin 10. So in the C code we'll be able to turn this on. And then we put a piece of wire here to go from the end of the resistor over to the base. Now the emitter here on the second transistor goes to ground. So when we have power sent to the base of both transistors, power will come into the lead, flow out through the collector to the emitter of the first transistor, then pass into the second transistor collector out through the emitter to ground. So we'll have a complete circuit because both, as in AND, transistors are turned on and the lead comes on. Again, same as the logical operation AND. Now here's our C code. Basically we've got two switches. You can call them whatever you want. We can call it switch, transistor, lead if we're working with LEDs. Maybe transistor is a good name. So you can see here, okay, we've set them up as output devices, but then we say here, we say digital write to switch 1 or transistor 1 high, digital write to switch 2 high, and then we print out through, we don't have any kind of display attached to this Arduino board, but we're going to use the we'll use the serial monitor in Tinkercad to display the print messages. The LED only comes on when both digital write to each switch is high. High means on. Digital write high low, digital write low low, digital write low high. The LED does not light.